Still feel it in complete, lifelike detail. They can feel their finger throb or imagine that they are flexing their hand. This is called phantom limb syndrome. We have a map of our body in our brains. Our limbs are full of sensory neurons responsible for feeling textures or the location of our body. Neural pathways carry this sensory input through the spinal cord and up to the brain. Since most of this neural pathway remains outside the limb itself, most of it remains behind after an amputation. At the site of an amputation, thickened nerve endings can become more sensitive, transmitting distress signals even in response to mild pressure. These signals should be restricted in the dorsal horn of the spinal cord. However, after an amputation, there is a loss of this inhibitory control and signals can intensify. Once sensory signals pass through the spinal cord, they reach the brain. There, the somatosensory cortex processes them. The entire body is mapped in this cortex. Sensitive body parts with many nerve endings, such as the hands, are represented by the largest areas. The cortical homunculus is a model of the human body with varying sizes proportionate to the size of the body part. The amount of cortex devoted to a specific body part can grow or shrink depending on the amount of sensory input the body receives from that body part. The brain increases cortical representation when a body part is injured in order to heighten sensations that alert us to danger. This increased representation leads to phantom pain. The cortical map is also responsible for the feeling of body parts that are no longer there because they still have representation in the brain. Over time, this representation may shrink and the phantom limb may shrink with it. But phantom limb sensations don't necessarily disappear on their own. Treatment for phantom pain usually requires a combination of physical therapy, medications for pain management, prosthetics, and time. Pharmacotherapy using opiates, morphine, and tramadol may help in the management of pain. A technique called mirror box therapy can be useful in developing the range of motion and reducing pain in the phantom limb. The individual places the phantom limb in a box behind the mirror, while the intact limb is placed outside in front of the mirror. The person then performs symmetrical exercises while watching the intact limb move and imagining that he or she is actually observing the missing limb moving. Some studies, though not all, have found that this exercise may help relieve phantom pain. Prosthetics can also create a similar effect. Many patients report pain when they remove their prosthetics at night. And phantom limbs in turn may help patients conceptualize prosthetics as extensions of their bodies and manipulate them intuitively. Acupuncture and spinal cord stimulation, in which tiny electrodes are inserted along your spinal cord and small electrical currents are delivered, can sometimes relieve pain. There are a plethora of unanswered questions about phantom limb pain. Researchers don't understand why some individuals with amputated limbs don't feel pain when they see an apparition limb, or why some individuals do not feel a phantom limb at all. The prevalence of phantom limb pain is unclear, with some studies reporting a high prevalence of 85%, while another reports a lower prevalence of 33%. Although there's no medical test to diagnose phantom pain, doctors identify the condition based on symptoms and circumstances, such as trauma or surgery, which occurred before the pain started.